Okay, question 3. We'll insert a calculator page. Now we're not actually going to do the solution of this question, we're going to show you how to simulate it. So what we're going to do is we're going to set up our class, and I'm going to define this class by pressing Control equals to be a list, and a list of 25 numbers. So to get a list, I'm going to press Control right bracket to get a curly set of brackets, and I'm going to give my 16 boys all the number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and all the 9 girls to have a value of 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so there's the whole class. Now if I want to just check I've got the correct number of entries, I could do the sum of the class, and I just do var, and this should give me 16. And if I want to do the dimension of this list, dim, again pressing var will give me class, I'll get 25. So I've got 25 numbers there, 16 of them are boys. Now what I'm going to do is I'm going to take a random sample from this class of 6 people without replacement. And so therefore the way to go about doing that is if I press catalog, there is a command called randsump. And randsump has a syntax: you have a list, you have the number of trials, and whether you want to have no replacement or not. So we're going to have the list being our class, we're going to have number of trials, so that's 6, and we're going to have the number 1 to say we're going to do it without replacement. So here we go. So random sum of class, we'll just paste it in, 6 and then 1. And therefore that's one sample of 6. I've happened to have got 3 boys and 3 girls there. Another sample, more boys than girls, and so on and so forth. So each time I execute this, I get a random sample. Now, if I want to count how many boys are in this, I simply do the sum of the random sample of that sample of 6, and that sample had 4 boys in it. That one had 4 boys in it. I'm just pressing enter each time. 3 boys, 4 boys, 3 boys, 3 boys, 4 boys. Come on, there must be more than 3 and 4. There we go, we've got 5. Okay. Now I'm going to set this little command up as a small function. I'm going to call it sample sum, ss just for short, and I'm going to give it a dummy variable. I'm going to call it k. K is not going to have any influence here at all. I'm going to have a control template to set it up as a function, and then just paste that in. And so now if I do ss of 1, that k won't do anything, but it's effectively the same as calling a random sample. And these numbers here, 1, 3, 3, 4, are exactly the same numbers as we had a moment ago. Okay, so what I want to now go ahead is run a simulation of taking lots and lots of samples of size 6. Alright, and executing this function sx will do that. So I'm going to do a sequence, and I'm going to store them in results. Alright, so I'm just going to create a function. I'm going to call it, I'm going to create a variable, results, just spelling out the word results. Control template, and that's just going to be a sequence, and the sequence is going to be depending upon me. I'm going to press var here to get my sum of the sample, and I'm just going to put n there. It's going to be a dummy variable. You'll see its lack of effect in just a moment, and I want to find out when that's equal to 3. In other words, I've got from my sample of size 6 3 boys, and I want to repeat this whole process from 1 to 1,000 times. And so what's going to happen, let's just be clear about this. This is going to generate a sequence, and the formula is this little one here, and it's going to generate either something that's true or false. If ss comes out to be 3, as it did a couple of times ago, it'll give me trues. If it falses, if it gives me anything other than 3, it'll give me a false. So if I press enter, it's generated 100 runs of this, and the first several runs seem to be rather false. Let's just press up and scroll right. Yes, there are a few trues in there, not very many, but this long list doesn't really help us see anything. We need a graph. So if I press Control Doc, I can see from the data and statistics application, those are all my results. There's a whole collection of trues and falses. And if I go down to click to add variable and choose results, I can see a bar chart, and I can see the majority are indeed false and the minority are true. If I want to go into empty space here and press Control menu on the keypad or right mouse click on the computer and choose pie chart, you can very quickly see that the percentage of times you'd expect this to be true under this simulation is 26.6%. or 0.266. Now, actually, just by sheer coincidence, if we looked at the solutions, we would get exactly the same decimal, but this does not always happen, and we're just going to show you that. So I'm just going to go back to my calculator page, and this results command, I'm just going to press enter one more time. It's going to rerun another 1,000 trials, so this is 1,000 more simulations. I go back to my pie chart, and it's only been true 290 times. So this varies. Now if I want to see these on the same screen at the same time, what I can do is on the keypad of the software or on your computer, you can press Control 4, and what that happens is it forces a split screen. Command 4 or Control 4 on the keyboard, whether you're Mac or PC, will do the same job. And so now when I've still got the flashing cursor on the left hand side, every time I press enter you can see a new set of results are generated, and the pie chart on the right is updated. You can see it just slightly shifting each time, and I can move the cursor over it and read off the percentage of the simulation. Now I've just limited it to 1,000 here. You could run it to 10,000, but obviously we're in the realms of this is best done on a computer. Now the situation for the second part of the question of students of all the same gender, then instead of just looking to find out when the sum is equal to 3, we're interested in when it's either 0 or 6. And therefore if I go over the results thing and just go back in and change the thing I'm interested in, instead of being equal to 0, instead of it being equal to 3, I'll make it equal to 0, or SS of n should equal 3. No, 6. Let's get all the numbers right. So this is now looking for 0, so that's no boys, so therefore all girls, or 6, which is all 6 boys. Pressing enter, we get a much different pie chart. This is not as likely. In this simulation of 1,000 runs, it only happened 5.5% of the time. Running it again, I got a slightly different value. 5.2% of the time, 3.8% of the time. So it's fluctuating around about 4%. So this isn't giving you the answer to the question, but it's simulating what actually happens if you were to do this in reality a large number of times. That's all we're going to do.